So let's do an example of finding the degree n-Taylor polynomial. So let's find the degree n-Taylor polynomial for the function. This is my function f of x, which I'm going to say is 1 over x at x equals 3. That's my a value, 3. So we found in the last video the answer. So the last video told us that the degree n-Taylor polynomial looks like a0 plus a1 x minus a, in this case a is equal to 3 to the first, plus a2 x minus 3 squared, and so on until I get to the nth term. And I have a formula for the kth coefficient. The kth coefficient is found by taking k derivatives of your function, plugging in a, and dividing by an extra k factorial. So what does this look like for our example? Here our function f of x is 1 over x. Maybe I'll write that as x to the negative first power. The derivative is negative 1 x to the negative 2 power. The second derivative, negative 1 times negative 2 x to the negative 3 power. The third derivative, negative 1 times negative 2 times negative 3 x to the negative 4 power. Now notice something. I am not expanding this out. I'm not writing this as negative 6 because I'd like to see a pattern, and patterns are easier when you don't expand it. In fact, I can kind of see the pattern now. The fourth derivative is going to be negative 1 times negative 2 times negative 3 times negative 4, x to the negative 5. Okay. I'm going to evaluate each one of these derivatives at 3. So what happens at x equals 3? So the first derivative would be 3 to the negative 1. The second derivative, negative 1, 3 to the negative 2. Oh, excuse me. The second derivative here, I claim I didn't want to simplify, but since I kind of see the pattern, I'm going to write this as negative 1 squared times 2 factorial, 3 to the negative 3. The third derivative, negative 1 to the third power times 3 factorial, 3 to the negative 4. The fourth derivative, negative 1 to the fourth power, 4 factorial, 3 to the negative 5. So in general, the kth value here will be negative 1 to the k factorial, 3 to the negative k plus 1. Therefore, my Taylor polynomial is the a0 term, which is 3 to the negative 1, plus the next term. The next term would be negative 1, 3 to the negative 2, divided by 1 factorial, x minus 3 to the first. The next, negative 1 squared, 3 to the negative 3 times, an extra 2 factorial over 2 factorial, x minus 3 squared. In general, the kth term is going to be negative 1 to the k factorial, 3 to the negative k plus 1 over k factorial x minus 3 to the k. And that continues on until I get to the nth term. I said find the degree n Taylor polynomial, so this will continue until I get to the nth power. So that's the answer. You might notice that these factorials all cancel. And you could even write this in a simpler form. Let's use sigma notation this time. So sigma notation will just help us write this whole polynomial out in an easier way. So I'm going to do the sum k going from 0 to n. K is going to be my exponent here. And then the kth term in general looks like negative 1 to the k, 3 to the negative k plus 1 power, and I'm canceling out the k factorials, and I have x minus 3 to the k power. So this would be a wonderful answer to the question of finding the degree n Taylor polynomial for my function 1 over x at x equals 3. What does this mean? This function approximates the behavior of 1 over x near x equals 3 very well. We'll see that in a future video. All right, thank you.